Hello everybody, here we are, 5.3, adding polynomials. And so a few notes before: when adding polynomials, you can either draw them as algebra tiles, or just drop the brackets and then combine like terms. If you remember in our definition of polynomials, it was terms, the sum of terms. And so they're already being added, even though sometimes we might have like 3x subtract 2, it's actually kind of a secret, like 3x plus -2. So when we're adding polynomials and we have something that looks like this, we can just drop those brackets because it's being added. The second part is being added, and that's typically what's going on in our regular polynomials. But I'm going to do a few drawing, and then I'll do a few without drawing. So let's draw these ones first. Remember, our x squared is going to be a box like that. A shaded in box is going to be an x squared, a negative x squared, negative. Our x is going to be a long, skinny one like this. Colored in one, skinny one like that, it's going to be a negative x. And a box like that, a little box like that, is just going to be a 1. And a little box like that, colored in, is going to be a -1. So let's draw these. We have an x. That's going to be a positive x, so a skinny one like that. And then 5 of our negative colored in ones. And we're going to be adding them to 2 x's. They're positive, so I'm not going to color them in. And then 2 of those positive ones. Now, to add them, we're going to first combine our x's. Looks like we have 3 of them, so 3x. And then our ones, we're going to look for 0 pairs. So these two are going to cancel out these two. They make a 0 pair. If you have the same shape, opposite colors, they make a 0 pair. And they equal to 0, so they cancel each other out. And what are we left with? These 3 negatives, so subtract 3. There you go, that's our answer for the first one. Let's do the next one. I'll draw it again. We have 1b squared, so I'm going to draw a square. And we have 3 b's, so it doesn't matter if it's x or y, what variable they use. If it's a single letter, they're going to be these skinny ones, positive. We're not going to color it in. That's going to be added to another 1b, b squared, so that box is positive, so I'm not going to color it in. And then there's going to be 3 of our negative b's, so I'm going to color them in. 2, 3. That's going to equal, okay, we have 1, 2 of these b squared, so 2b squared. And then these 3, so these 3 positive ones are going to get canceled out by these 3 negative ones. They're going to make 0 pairs. So the answer is just 2b squared. And then finally, I will do the next two, not using algebra tiles, just dropping the brackets. So here we have an x squared, subtract 4x plus 3 plus, so negative x squared, subtract 2x, subtract 3. And now let's combine our like terms. So didn't really need to draw that plus. I'm going to get rid of that. I don't want to confuse you. And let's see where our like terms are. So we have an x squared and we have a negative x squared. Okay, those are only x squared. Now we have a negative 4x and we have a negative 2x. And finally, we have a positive 3 and a negative 3. So let's add up our like terms. So here we have a positive x squared and a negative x squared. That's just going to be 0. So that's that. We have a negative 4x and a negative 2. So negative 4 plus negative 2 is going to be negative 6x. And finally, we have a positive 3 and a negative 3. That's going to be 0 again. So our answer is just negative 6x right there. Okay, I'll do the next one. I'm just going to drop the brackets on this one. I won't draw it out. So negative 3d squared plus 2. So I'm going to just ignore that plus and go negative 2, subtract 7d squared plus d. And now let's combine our like terms. So we have a negative 3d squared, and here we have a negative 7d squared. Let's do the next ones. I have a positive 2, I have a negative 2, and that's it. And finally, I have this positive d on its own. So let's add them up. Negative 3 plus negative 7 is negative 10d squared. Let's not forget this part. And our next part, we have a positive d, nothing else to go with it, so plus d. And this positive 2 and the negative 2 are going to cancel each other out. So that's our final answer. It's a d. Negative 10d squared plus d. Okay, so similar to just, combining our like terms. And let's go on. Yeah, I feel like they love to have perimeter questions with polynomials, and it's kind of related to, if you want to have something with particular dimensions, you can use variables to kind of like control the size. Think about like, making a picture bigger or smaller. You want it to grow at like a consistent rate so that it doesn't get all warped. So for each shape below, write the perimeter as a sum of polynomials in its simplest form. So remember, this side in a rectangle is going to be the same as this side, and this side is going to be the same as this side. So we're looking at 2n plus 2. Remember, perimeter is all the way around. So one side is 2n plus 2, plus this side right here is going to be n plus 1, plus this side again, which is the same as that one. So plus 2n plus 2. And I'll do our last one down here, plus this side, which is the same as this side, n plus 1. Now let's combine our like terms. So we have a 2n and an n and another 2n and an n. So we have 2 plus 1 plus 2 plus 1. So 3 plus 3 is going to give us 6n. And then our other like terms, we've got a 2, our constants, a 1, a 2, a 1. So 2 plus 1 plus 2 plus 1 is positive 6. So this is our polynomial statement for the perimeter of this rectangle. Next we have a triangle. So let's, these little lines mean that all the sides are equal. So each side is going to be 3p plus 4. So we're going to do that 3 times, plus 3p plus 4 plus 3p plus 4. Now let's add up our like terms, the 3p, 3p, 3p. So that's going to be 9p. 3 plus 3 plus 3 is 9. And plus our constants, so our positive 4, positive 4, positive 4. 4 plus 4 plus 4 is 12. So that's our polynomial for the perimeter, or all the way around this triangle right there. Finally, this is a sum question, but in a way it's kind of a subtraction question, but let's do it as a sum. And I'm going to draw this one. I think that's a good way to do it. So the sum of two polynomials is 4r plus 5 subtract 3r squared. So this is going to be our answer. So I'm going to draw it here. Let's do our 4r's. They're positive and a single variable, so they're going to be those long algebra tiles. And then we also have a positive 5, so I'm going to draw 5 ones. I'm not going to color them in. And then we have a negative 3r squared. So our squares, it's negative, so I'm going to color it in. Next, we got this one. And our last one, 3 negative r squared. Okay, so that's where we want to end up, negative 3r squared plus 4r plus 5. And one polynomial is this one right here. And what's the other polynomial? So explain how we found our answer. So we're going to go, this is our kind of question mark here. And I'll show you our other one. I'm going to draw it right here. So we have negative 8 ones, 2, 3, 4. They should be colored in. I'm drawing this polynomial right here. So I'm doing these negative 8s right now. And 4 more. Okay, we've got our negative 8. And next I'm going to draw this negative 2r squared. So 2 square ones. And they're negative, so I'm going to shade them in. That's negative 2r squared. And our last one, positive 2r. So just 2 of those long ones, positive 2r. So how do we get from here to here? Well, looks like we're going to need one more. So we have 2r squared, negative r squareds right here. We're going to need one more. So we know this one is going to have one negative r squared. Okay, let's look at these ones next. Our r's. So we have 2 currently. We need to get to 4. So this one here is going to need to have 2 positive r's. It's not a very good. There we go, 2 positive r's. And finally, okay, we got 8 negatives and we need to get to 5 positives. Okay, this one's a little bit tougher. So we're going to need to have a bunch of positives to cancel out all these negatives. So we're going to need to have at least 8 positives to cancel those out, plus 5 more. So this is going to be 8 plus 5. This is going to be a lot to draw. We're going to have 13 of these. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So now when the 8 of these ones are going to cancel out 8 of these ones and leave us with 5. I feel like this looks like I'm a football coach and I've just drawn a bunch of really confusing plays. But I'll write the answer down here. So this means that negative 2r squared plus 2r subtract 8, that's our polynomial right there, plus this one that we just wrote, that's a negative r squared plus 2r plus 13 is going to equal our final polynomial right here, negative 3r squared plus 4r plus 5. Okay, I'll give you a chance to write all that down. I'll let you know what textbook questions I'd like you to do. Thank you very much.